Let's look at the concept of frequency and cumulative distributions. Since continuous data has many more different possible values, creating a frequency distribution requires a bit more effort. Remember, with the categories, it was a little simpler because we only had 3 levels. But when we have a continuous variable, I could have 100 or 200 or 300 values, and that's going to be a little bit hard to create this frequency distribution, but we can do it. So let's take an example here. Let's say that we have a data set with grades for 21 test scores. Now here I've noted it 1 through 7. The ... means everything from 8 all the way through 20, and then the last one shown 21. The grades are on the right, 91, 96, 89, and so forth. Creating a chart that shows the distribution of data could also give us some good insight into this data. A chart of all possible values is not going to provide some good information. There are just simply too many values to provide anything meaningful. So this would be equivalent to a bar chart for each one of the grades. You can see it really doesn't tell us that much. In order to provide a meaningful chart, 3 things need to be determined. We're going to group the grades into a number of bins or groupings. Normally, a good selection is going to be an odd number. Generally between 3 and 9 should do well. So we're going to take all of those grades and we're going to put them into 3, 5, 7, or 9 bins. Now what we need to do is determine the size of each bin. Each bin should be of equal size. However, sometimes the left or the right tail might be larger than the other bins. That's okay. What we want is all the middle bins to be the same. By selecting the size of the bin, the upper and lower limit of each bin will become apparent. In other words, when we choose the bin and we choose the size, we know we're going to start at a minimum. We know it's going to be a certain size, let's say 10, and then the next one will go from, say, 11 to 20, and so forth and so forth. It begins to clearly delineate the bins themselves. In this example, we're going to compute the range of the data. In the actual data, the minimum is 60 and the maximum is 96. Therefore, the range is 36. Again, the data is available for you separately. Make that available, and you can use that. Again, with our Excel video, you'll have that. We're going to determine the number of bins we need, 3, 5, or 7. And then what we're going to do is we're going to divide the range, which we counted as 36, by the number of bins to determine the size of each bin. So if we choose 3 bins, we're going to have a bin size of 12. If we choose 5 bins, we'll have a bin size of 7. And if we choose 7 bins, we'll have a bin size of 5. Finally, we will determine the range of each bin in which the frequency counts will be determined. So the bin ranges below can be used for the frequency counts. So if we have 3 bins, each is a size of 12, it will go from 60 to 72, then 73 to 84, and then 85 to 96. Now in the case of 5 bins, each one of size 7, it'll be 60 to 67, 68 to 74, 75 to 82, 83 to 89, 90 to 96. And in the case of 7 bins, each with a size of 5, we'll go from 60 to 65, 66 to 70, 71 to 75, 76 to 81, 82 to 86, 87 to 91, 92 to 96. Now you're going to notice that first bin for both 5 bins and 7 bins is a little bit larger, because if I do 60 to 67, there's actually 8 in there. I've just put that left tail to have that extra one. I could have put it on the right side, but I just chose to have it on the left side. Will not really change the outcome of the results. So we're going to choose 5 bins for the distribution of the grades. The following frequency table is then computed. So we have our bin 1, which goes from 60 to 67. There are 7 grades in that bin. In bin 2, which is 68 to 74, there are 3 grades in that bin. In group 3, which is 75 to 82, there are 2 grades within that bin. In bin 4, there are 3 grades between the grades of 83 and 89. And for number 5, there are 6 between 90 and 96. From there, since we know that there were 21 items, we can take each one of those, 7 divided by 21, and we will get a frequency distribution of 0.33. We'll do the same thing for all the others. 3 divided by 21 is 0.143. 2 divided by 21 is 0.095. 3 divided by 21 again is 0.143. And 6 divided by 21 is 0.286. Multiplying each of those by 100, we will get 33.3%, 14.3, 9.5, 14.3, and 28.6 as a percent distribution. The relative distribution shows that the highest count, which we've highlighted in green, occurs between 60 and 67. Maybe the students didn't do so well on this one. And the fewest are between 75 and 82. And it's showing kind of like a dip here in the middle. We can see how it starts at 33 high, then 14, then 9, then 14, 28. So I can see there's a wide range of students' grades here from that very low to the very high. Now, since each bin or level represents a range of possible numbers, the midpoint of the range is called the level midpoint or the class midpoint and gives a general value for the bin. So we would basically take 60 to 67. I have an average or midpoint of 63.5. We're just taking the center point between 60 and 67, or the center point for each one of the bins, which is 63.5, 70.5, 78.5, 85.2, and 92.5. Now, a cumulative distribution is the relative frequency, but basically adding each one up so that we sum up every bin to get to 1. So if you'll see here, we have the percent distributions, 33.3%, 14.3%, 9.5%. We're going to use the frequency distribution column over here to the left. And the reason we're going to do that is because it's a little bit easier for us to add instead of dealing with the percentage number. But you can do the same thing. Instead of adding up to 1, they'll add up to 100%. So here, we'll take each one, starting from the beginning. The cumulative distribution at bin 1 is 0.33, because there's nothing before it. When we add the second bin, the cumulative distribution becomes 0.476. It means everything from this distribution before it is going to add up to 47%, but 0.476. When we take the third bin, we're going to add all the previous ones as well, and we're going to get 0.571. And we repeat this until we get 1.00 or 100%. So the cumulative frequency distribution at any point is the total percent of all observations that have occurred prior to that given point, including the point itself.